welcome back to GDC classes. I welcome you all to this platform of GDC classes English for our digester videos. As you all know by now, this digester series is very important when you are preparing for your GPAT 2026 examination. In very few days we have our exam, but GDC has launched this series specifically for this examination to help you all inculcate all the important topics in a way we cover the topics as well as their previous year question in one short video. I hope this video would put so much information into one concise manner that you all are going to take a lot of important notes from. So let's begin with our first video of digester straight from your physical pharmacy, and followed by that we will have our MCQs as well. So methods for the particle size determinations in itself is a very important topic when we talk about our exam, right? So first topic here is that is the number one is the microscopy method. Now every detail, each and every point you see here has to be noted down for your exam point of view. Okay, I will try to help you mark down every detail of it. Okay, first thing is the microscopy method. As the name suggests, microscopy, that means this optical microscope is going to be used. Into the size range it can measure up to 0.2 to 200 micrometer. Each and every word that is written here is hell important. Okay, 0.2 to 100 micrometer particle size range can be estimated using this optical microscope. Now what diameters can we evaluate? We can evaluate our ferret's diameter, Martin's and projected diameter. All three words are important: ferret, Martin and projected diameters. Okay. Then we have our TEM, transmission electron microscopy. Because this is a simple microscope and it takes a lot of time, but also it does not give any value to the depth, right? And proper estimation cannot be done. So for that reason, we had to switch to even precise electronic microscopes like transmission electron microscope or even scanning electron microscope, right? Here we have a size range of 0.0012 to 0.1 micrometer, right? And we have for the SEM as well, right? So TEM is the transmission electron microscopy, SEM is the scanning electron microscopy. Then we have our light microscope, for which we have a 0.12 micrometer in size, right? So this is a simple where only two dimensions we can estimate, the length and the breadth, but thickness cannot be estimated. Also counting the agglomerates can add to a certain challenge. So these are the microscopy method. Exam point of view, important are these size ranges as well as the diameter names. Then second method we have a sieving method. In the sieving method we use the mechanical shaker machine in which all the different sieves are stacked one upon another based on their grading. Okay, the particle size which can estimate is 50 to 1500 micrometer. We have a standard size which is already given in your books. Based on the particles will be then coarse, fine and superfine based on the grades of the sieve. Okay, important thing here, sieve shaker is used and the size range you get is 50 to 1500 micrometer. Third is the sedimentation method, which is yet another very important method. The size range is around 1 to 200 micrometer. Here you use Anderson pipette or gravity sedimentation method based. This is an apparatus. We call it as Anderson apparatus or Anderson pipette, which is basically used for the particle size estimation based on the sedimentation technique. Okay, so here we have one important diameter that we always talk about, that is the Stokes diameter. I'll write it here for you all. Stokes diameter or the Stokes law equation, which states that velocity of the particle sedimentation is directly proportional to the square of diameter into the density difference upon 18 eta. Now this is a Stokes law equation which gives us an idea that velocity of the particle settling is directly proportional to square of diameter and inversely proportional to the viscosity. That means if you have a higher bigger particle or the diameter is larger, then the sedimentation can be quicker. If the viscosity is lower, then the sedimentation can also be quicker. So this is a sedimentation method based on the Stokes law equation, right? And resin pipette is basically based on this, and you can see how many times it has been asked in the different exams. Now that becomes specific to our GPAT 2026 exam as well. Then we have our conductivity method. If you can't see, that is written conductivity. So based on conductivity, we can measure up to 0.5 to 500 micrometer particle size. That is done using the instrument known as Coulter counter or 𝘂𝙎𝙎𝘖𝐴C. Now all these are based on the particle number, particle count or size method. Only this method we can estimate our particle volume as well. Only through this method, we call it as conductivity method, we can measure up for the particle volume as well. This is very important, and all the points I have mentioned is very important. Now let me introduce you all to the very great launch of the GDC from we have our Pharmacology Kundli book. I hope you all have definitely check that out. If not, please go out and check this book for the drug classification for the pharmacology. Okay, next we have our questions based on what we have learned so far in the methods of particle size determination. Number one question we have is type of diameter obtained by the microscopic method of evaluation. Whatever we will cover, I will try to divide it into questions how it can be framed and has already been asked. So we have seen projected diameter, we have seen volume surface, surface volume or Stokes diameter. Stokes diameter is in the case of the sedimentation method like in resin pipette method. So here we have our projected diameter, right? Other we have our Martin's diameter, we had our Ferret's diameter and all those. Okay. Next question, the particle size range that can be analyzed by the optical microscopy method is, I told you the range itself is another adding to the important topic. So for the optical microscopy, it is around 0.5 to 150 micrometer. Okay. Next question, the instrument used to measure the particle volume. I told you all the instruments we have studied so far, only the Coulter counter method, which is based on the conductivity, that is important for the particle volume measurement. Okay. Also, every question you see here, if you want to prepare with us, in the comment section, always try to put up your score, how much have you scored and what digester videos you would like us to make for you all in these limited time, so that we can help you with your preparation. And I have said it so many times, and today also, GDC is here full on dedicated for your preparation stage, as well as even after preparation stage. We all are here to support you. Comment section is freely available. You can tell anything you would like to share there, and I personally go through each and every comment. So make sure whatever your doubts are, I try to address these doubts in my upcoming videos as well. Okay. Second question, let's move on to the next. We have one of the following apparatus is used to determine the particle size by the gravity sedimentation method. Only one method here we can emphasize on, that is mainly useful for the particle size determination by the sedimentation method, would be the Andreessen apparatus. Now from now you can mention two more: Andreessen apparatus, pipette method, and one more is the hydrometer method. Those who knew, that is excellent. If not, please note down Andreessen apparatus, pipette method and hydrometer method. All these three are gravity sedimentation based method. These can be asked in your exam. Okay. Next, Coulter counter method is used to determine the particle interaction, viscosity, number or size. Overall, we know that the Coulter counter method is based on the conductivity for the particle volume measurement, right? Now the particle volume, size, etc., all these can be interrelated and correlated with the particle size, number, weight distribution, volume, diameter. All these can be used to calculate your particle size. So overall, we have our answer to the question, that is the particle size measurement. Okay. Then in the formulation of suspension and emulsion, Which type of diameter is important? Projected, surface, volume, or Stokes? As I've mentioned, the formulation suspensions you can see here, these are able to show the sedimentation. So based on the sedimentation method, we have our diameter, we call it as Stokes diameter. We have well studied in the Anderson apparatus that Stokes diameter was in the sedimentation based method. So for the suspension emulsion, we have our Stokes diameter. Next, the instrument used for measuring the particle volume can be helium densitometer method, Hampel-Burette, microscope, or Coulter counter method. Do I need to tell it again? No. Particle volume measurement is done via the Coulter counter method, which is a conductivity based method. Next, Anderson apparatus is used for the determination of particle charge, size, count, and shape. So you all know particle size measurement we are talking about for the Anderson apparatus, pipette method, hydrometer method, and balance method. Three methods. Anderson, pipette method, balance method, hydrometer method, all these three are for the particle size measurement based on the sedimentation method. Option B here is correct. Next, Coulter counter is used for the determination of Coulter counter method is used for the determination of your particle volume, particle size, and that can be correlated for the particle surface area. So all these terms can be very much correct. Next, the following technique measures the particle size of about 100 nanometers. So in the nanometers, we are going down from the micrometer. So we need a specific type of instrument. So our microscope, which is electronic, can be definitely used. SEM TEM can be brought down to our nanometer ranges. So this is all about this important topic digester video. I hope you have enjoyed watching it. And please, if you are preparing for GPAT 2026, make sure to fill up the comment section with your suggestions, any confusion topics, or even your feedbacks or what kind of digester topics you want from us. This comment section is open for you all. Otherwise, if you are watching, make sure to put your scores as soon as the video ends. And with the questions you are attempting, please write down in the chat box so even I know how many students have attempted. Thank you so much. We will meet in the next video. Till then, all the very best. Days are very near to us for your exam, but we will not miss any chance for your preparation. Thank you so much. We will meet really soon.